All right, today we're diving into something pretty amazing. We're going to go on this tiny, super fast adventure to uncover the secret journey that sound takes. From your phone all the way to your eardrums. It all happens in a flash, but believe me, it's an incredible story of transformation.
No, really think about it for a second. You just tap your screen, right? And a split second later, a whole orchestra or this huge bass line or someone's voice is just perfectly recreated right inside your head. How on earth does that actually happen? Well, in those few milliseconds it takes for a song to even start, this incredible journey unfolds. It's a journey of translation, then amplification, and finally creation. So let's start at the very beginning of that journey.
Okay, so to really get this, we have to meet the hero of our story, the audio signal. The best way to think of it is like a tiny electronic messenger, and it's carrying the secret blueprint for a sound. And our job today? We're going to follow this little messenger from the absolute start of its mission all the way to the finish line.
So, our little messenger's journey kicks off in a place it was born, sure, but it's a world our ears just can't understand at all. We're talking about the digital world. And this is the first crucial step, where it has to transform from just abstract code into a real physical electrical current.
And right away, that's the first huge problem. See, every song on your phone, it isn't actually sound. It's data. Just a long, crazy complicated string of ones and zeros. It's the language of computers, not the language of music. So the big question is, how do we get from raw data to actual sound?
Yeah, the signal literally has to change its language. It starts out as this, kind of blocky, step-by-step digital info, computer speak. But what it needs to become is this smooth, flowing, continuous analog wave. An electrical current that perfectly mimics the shape of a real sound wave. That's the goal. And to do that, you need a translator. And guess what? Every single modern audio device has one. It's called a digital to analog converter. Or you'll just hear it called a DAC. You can honestly just think of the DAC as the little magic box in the whole circuit. It's the one part that reads that digital blueprint, all those ones and zeros, and somehow perfectly translates it into that smooth, flowing electrical current. And boom, we have our brand new analog signal. Okay, so great. Our messenger has been translated. It's now speaking the language of sound. But it's immediately hit another problem. It's basically whispering when it really needs to be shouting. The message is perfect, but it just doesn't have any power behind it. So the DAC does its job perfectly, right? It creates this beautiful, really accurate signal. But it has almost no energy. Like, if you tried to send that signal straight to your headphones, you'd barely hear a thing. Maybe nothing at all. It's got all the right information for sure, but it just doesn't have the muscle to actually do anything with it. And that is where the next hero of our circuit steps in, the amplifier. The amp is basically a megaphone for our tiny little audio signal. Its only job, is to take that weak but perfect signal and just give it a massive power boost. It makes it strong enough to physically move stuff, specifically the parts inside your headphones. You can really see the difference here. That signal coming out of the DAC, almost no energy. But after it goes through the amplifier, whoa! Its power is just boosted enormously. And what's super important to notice is that the shape of the wave, the actual music part, is exactly the same. It hasn't been changed at all. It's just been given the raw power it needs to finish the job. So here we are. Our signal is translated, it's powered up, it has reached the very end of the wire. And now it's ready for its final and honestly most magical transformation, making the leap from being just electricity into becoming actual sound in the air. This strong electrical current flows all the way down the line and into the little speakers inside your headphones. Now, these tiny, complex little things are called drivers, and you can think of them as the final gatekeepers standing between the world of electricity and the world of sound. Really, the best way to picture a driver is to think of it like a tiny, super precise drum. And at the very heart of this drum is a thin, little membrane called a diaphragm. This is the thing that's going to actually make the sound. It's just sitting there, waiting for orders from our audio signal. Okay, so here's how it all comes together. Step 1, our super strong signal finally arrives. Step 2, that electrical energy causes the diaphragm to start vibrating like crazy. We're talking thousands of times a second, and it perfectly copies the shape of that analog wave. And then, step 3, all those vibrations start pushing and pulling the air molecules right next to them, creating these pressure waves. And what are those waves? Well, that's sound. That's what your eardrum picks up. The journey is complete.
So we followed the whole thing, right? From code to an electrical current to a physical vibration. It's a really cool technical process, for sure. But why does any of this actually matter to you when you're just listening to music? Well, let's just quickly run through that chain one more time. It starts as a digital file, just code. The DAC acts as the translator, turning it into a weak analog signal. The amplifier is the megaphone, giving it power. And finally, the driver, our tiny drum, vibrates to create the sound waves. And here's the thing, every single step in that chain is absolutely crucial. And that really gets to the heart of it all. This isn't just some boring electronics lesson. This is the basic blueprint for how we experience almost all recorded music today. It's actually a beautiful piece of engineering that most of us just carry around in our pockets every single day. And this is the big takeaway. The quality of the sound you end up hearing, it's only as good as the weakest link in that chain we just talked about. A better DAC means a more accurate translation, a better amp gives you clean, strong power, and a better driver can vibrate with way more precision. This is why different headphones or different phones or different music players can sound so wildly different from each other.
So the next time you pop in your headphones and hit play, you'll know about this incredible secret journey that's happening in just a split second. Now you know the blueprint. And who knows, maybe you'll listen just a little bit differently. Maybe you'll pay attention to the clarity, that's the DAC, or the raw power and punch, that's the amp and the driver. Now that you know how it all works, what will you listen for next?